Year 10 Physics, Acceleration 2. In this video, you're going to be learning how and when to use the equation v squared minus u squared equals 2as. And in a moment, I'll explain what those terms all mean and where you can find that equation. But before that, I want you to pause the video for 5 minutes and do the formula quiz. So pause now, please. The answers to the quiz: number 1, acceleration equals change in velocity divided by time, or you might have used a equals v minus u all divided by t. That was the last video. Number 2, force, distance and work done. Work done equals force times distance. Number 3, force equals mass times acceleration. Number 4, distance equals speed times time, or you might have said speed equals distance divided by time. Number 5, potential difference equals current times resistance. Number 6, power equals current times potential difference. Number 7, you could either say power equals energy divided by time, or energy equals power times time. Number 8, kinetic energy equals 0.5 times the mass times the speed squared. Number 9, gravitational potential energy equals mass times gravitational field strength times height. And number 10 is the equation that's in the box at the top there. Final velocity squared minus initial velocity squared equals 2 times acceleration times displacement. And as far as this lesson is concerned, we can treat displacement as being the same thing as distance. Now, there are some equations in physics known as the suvat equations because S, U, V, A and T are the letters that stand for the quantities. Okay, so in the box there we've got symbols S for distance, U for initial velocity and V for final velocity, A for acceleration and T for time. We should be starting to get familiar with those already from the previous video. So we've already done one equation for acceleration, but what if you're not given the time? Well, there's another equation. The final velocity squared minus the initial velocity squared equals 2 times acceleration times distance. Now, I don't know about you, but I find it quite difficult to write that out longhand all on one line. That is one big equation. So instead, I prefer to use the symbol version. V squared minus u squared equals 2as. There's some good news coming up. That one is given on the physics equation sheet. The one that was from the previous video, you do have to memorise, you will not be told it. But v squared minus u squared equals 2as. If you're doing GCSE separate science physics, it's the second equation on the equation sheet. If you're doing combined science, it's the first one. All right, so let's see how we use that equation. I'm going to talk through these two examples. If you think, no problem, I can do algebra, then you go ahead, pause the video and try and work them out and then play the video back to check. So the first question here, just like in the previous video, I don't really care what the context is. All I'm looking for really is what data have they given me and what do they want me to calculate. So that's what I'll look for first of all. We've got some hidden information here. It tells us a car sets off from traffic lights, so it presumably was stationary. It reaches a velocity of 20 meters per second. So we've got U, we've got V, we've got the distance of 100 meters, that's S, and we have to calculate the acceleration, that's A. So I've got my data listed as before, so I don't have to go hunting through the question to find it. Next thing, always write down the equation you're using. The examiner will be looking for it. And then substitute exactly in the order that the equation is. because the examiner is looking for that as well. Give the examiner what they want to see and make it easy for them to give you the marks. Next stage, we can work out what we can. 20 squared take away 0 squared is 400. 2 times 100 is 200, and then I've still got times a. So the answer must be 2, and then give the units, meters per second squared. The next one, same thing, different numbers. Pick out the information. We've got an initial speed of 1.5 meters per second. We've got a final speed of 6 meters per second. We've got a distance of 20 meters, and we have to calculate acceleration. So list the data, write down the equation every single time, even when you really don't want to, just make that a habit. Substitute without working anything out first, because the examiner is looking for that substitution. Work out what you can, and then find the answer and give the unit. Okay. Pause the video for about 6 minutes, maybe 3 minutes a question. Have a go at these. Pause the video. Okay, let's look at the answers. Mark it as you go along. So for this one, you would get 1 mark for substituting. So for the 12 squared minus 0 squared equals 2 times a times 60, you're going to mark for that. You'll get a mark for the next line. You'll get a mark for getting the answer of 1.2 and a mark for writing down the units, meters per second squared. So that would be a 4-mark question. For the next one, same idea. A mark for substituting correctly, a mark for doing some rearranging, a mark for getting the answer, and a mark for writing down the units. Okay, here is another set of worked examples, but this time we're going to find S, the distance. Again, if you want to work these out yourself and then watch my talk through of it, that's absolutely fine. Pause the video and do that. If you just want me to show you how to do it, that's fine. Keep playing. Okay, so I need to pick out my data every single time. Sets off from traffic lights, so again, that means it must have been stationary, so the initial velocity is 0. The rest of it is easy to pick up. We've got the acceleration of 5 meters per second squared, the final velocity of 20 meters per second, and we're asked to calculate the distance. So we write down the equation, we substitute in the data we've got, so 20 squared minus 0 squared equals 2 times 5 times s. Be careful with your handwriting here. You can see that I've got a problem that my 5s and s's look very, very similar. So be very clear to write your numbers and your letters without being ambiguous. So do some working out. Well, 20 squared minus 0 squared is 400. 2 times 5 is 10, so 400 equals 10 times s. So s must be 40 meters. That's probably a 3-mark question, because it's unlikely that they're going to give you a mark for knowing that distance is in meters. That's a little bit too easy for GCSE. Next example, similar thing. But this time, there's an extra part to the question. So let's look at what we've got. We've got an initial speed of 100 meters per second. We've got an acceleration of 3 meters per second squared. We've got a final velocity of 200 meters. We have to calculate the distance and then give the answer in kilometers. All right, start with the equation every time. Substitute what you know. So we get 200 squared minus 100 squared is 2 times 3 times s. Work out what you can. So 200 squared minus 100 squared is 30,000. 2 times 3 is 6. So 30,000 equals 6 times s. So S must be 5,000 metres, 30,000 divided by 6, which is 5 kilometres. If you'd left your answer as 5,000 metres, you would lose a mark. You probably know the routine by now. You're going to pause the video for about 6 minutes and then I'll show you the answers. So pause the video if you've not done it already. Ready for the answers? Pick out the information. Starts from rest, that means the initial speed is 0. Write down the equation. Substitute. Work out what you can. That's 225 equals 5 times S. And get your answer. So 225 divided by 5 would be 45 then, M for metres. The next one, exactly the same process. You pick out the numbers and what they stand for. So we've got the initial speed of 7, the acceleration is 3.6, final speed is 11, and the distance, write down the equation. Substitute in what you know, work out what you can, and work out the answer. So we end up with 10 metres. Next thing you might be asked to do on an exam with that equation is find one of the speeds. So let's look at how to find v, the final velocity or the final speed. Okay, a bus sets off from rest, so u equals 0. It accelerates at 3 metres per second squared for the next 80 metres. So there's all our data. Calculate the final velocity and then answer to 2 significant figures. So we write down the equation. We substitute what we know. V squared minus 0 squared is 2 times 3 times 80. Work out what we can. V squared equals 480. So V equals the square root of 480, which comes out to 21.9. So you have to round that to 22 metres per second. For the next one, car being driven at 15 metres per second accelerates at 0.4 metres per second squared over a distance of 1.2 kilometres. Calculate the final velocity. Well, we're given the distance in kilometres, but we don't use kilometres in our equations. We need metres. So 1.2 kilometres is 1.2 times 1,000, 1,200 metres. Write down the equation. Substitute what you know. Work out what you can. So V squared minus 225 is 960. So that minus 225 comes over the other side, becomes plus 225. So V squared becomes 1,185. The square root of that, the final stage, comes out to be 34 metres per second. Right, these are a little bit more complicated, so when you pause the video this time, I want you to give yourself around 4 minutes per question. Okay, pause the video. Ready for the answers? Right, the first one has got a little bit of red herring information there. It talks about a sprinter in the 60-metre dash. That 60 metre is not relevant to the question. It's just the name of the race the sprinter was in. What is important is that they set off out of the starting blocks, so their speed initially must have been 0. Then we've got the acceleration, we've got the distance, and we have to calculate the final velocity. So you write down the equation, even if you think you don't need to. You substitute the data. You work out what you can. So we end up with V squared equals 180. You remember to do the square root. And I'm going to give the answer to 2 significant figures, even though it hasn't asked me to, because it's good practice anyway. And of course, I'll remember the answer is a speed, so it's metres per second. The next one, same idea. list all the information, convert your units if you have to. We've got 0.5 kilometres, that's 500 metres. Write down the equation, substitute what you know, start working things out. So v squared minus 144 equals 200, v squared is 344, and the square root of that comes out to be 18.5 something, so the answer is 19 metres per second to two significant figures. Now, all that working out might look like a bit of a palaver, but it's there to help you show the examiner that you know what you're doing. If you get a question like this and you think, oh, that's no problem, I can rearrange it in my head, I can do it all in my calculator, and I can just write down my final answer, you risk not getting the marks. Because if you make one little mistake, you're not going to see it. And the examiner is not going to see where you've made the mistakes. So you could end up potentially losing 4 or 5 marks on a complicated question if you don't show you're working. Okay, so we have 2 activities here. You've got activity 1, which is a worksheet. I want everyone to do page 1. That's calculating acceleration and calculating distance. If you're doing higher tier, I want you to do page 2 as well, which is calculating the final speed or the initial speed. And if you think that's no problem, then have a go at doing the challenge, which is activity 1B, deceleration. So what happens if you're not speeding up but you're slowing down? Give yourself about 20 minutes on it, so you don't have to do every single question. There's 4 questions in each group, so you could do, 2 of each. And then 5 minutes to mark what you've done using the model answer sheet. Okay, now I want you to pause the video again, and you're going to do activity 2, which is the exam questions. And then come back to the video once you've done them and self-assess using the live modelling that comes up in the rest of this video. Acceleration 2 exam questions. Now, this equation is quite new in the AQA GCSE specification, so there are only actually a couple of genuine GCSE questions on this. These questions have been taken from AS papers and edited, so they might be quite challenging in places. So if you found them quite difficult, don't worry. If you found them quite straightforward, well done, that's brilliant. Now, the same process that we've gone through in the rest of the video applies here. We pick out the data and we write it down, we write down the equation, and we work out the answer. So, we've got a question about a roller coaster. I honestly don't care what the question is about. It's not important. What's important is picking out the information. So the train accelerates from rest, so u equals 0, to a speed of 58 meters per second. So v is 58 meters per second in 3.5 seconds. Calculate the average acceleration. So this is a question like the ones we were doing in the previous lesson. So the equation we need to write down is the one that we're not given in the exam. A equals v minus u divided by t. And then we substitute in what we know. A is what we're finding out. V was 58, u was 0, t was 3.5. We work out the answer, that comes to 16.57 something. But the question tells us we want 2 significant figures. So that would round to 17. Now, I can now fill in this A. (17 meters per second squared). And the next question tells me to calculate the distance the train moves while accelerating from rest to 58 meters per second. So we're still using the same list of data because it's still the same train, still the same question. But this time it's saying what is S. So the equation I need to use this time is v squared minus u squared equals 2as. Then I need to substitute in the information that I know. So I can say 58 squared minus 0 squared equals 2 times 17 times s. Try and make that more like an s and less like a 5. Not sure I've succeeded. Right, 58 squared minus 0 squared is 3,364. 2 times 17 is 34. So my equation becomes 3,364 equals 34 times s. So to find s, I need to do 3,364 divided by 34, which is 98.9. So that rounds to 99 meters. Now, if you stored the 16.57 in your calculator and used that for this question, you might have got 100 meters. And that's fine. In the exam they would accept that as long as it was clear what you'd done. Question 2. A car of mass 1,300 kilograms is stopped by a constant horizontal braking force of 6.2 kilonewtons . Show that the deceleration of the car is about 5 meters per second squared. So we're looking for deceleration, which is acceleration only negative. So this is something that you will find in higher tier questions, especially the more demanding ones. You'll get questions where you get 2 or 3 parts that are using different equations. Right, the one we need here is F equals m times a. Now we substitute what we know. Now 6.2 kilonewtons, that's no good. We need to use 6,200 newtons. We must convert our units. So 6,200 is 1,300 times the acceleration. The acceleration, 6,200 divided by 1,300, which comes out to 4.8 meters per second squared, to 2 significant figures. Now the reason that they've said up here, show the deceleration of the car is about 5 meters per second squared, is if in the exam you couldn't do that question, you then got a value you can use for the rest of the question. So I'm going to use the one that I worked out, but if you didn't get that and you used 5, that's okay. Let me just move the camera down a bit. There we go. So I'm going to add to my data here a 4.8 meters per second squared. It's also telling me the initial speed is 27 meters per second. And we have to calculate the distance travelled by the car as it decelerates to rest. So v equals 0. So the equation I want to use is v squared minus u squared equals 2as. Then I'll substitute in my data. 0 squared minus 27 squared is 2 times, be careful, acceleration 4.8 times s. Now, I need to be super careful here because the acceleration is a deceleration. It's negative, and I must put that negative number in or I will get the wrong answer. Alright, if I work that out, 0 squared minus 27 squared is minus 729. 2 times minus 4.8 is minus 9.6 times s. That means that s must be minus 729 divided by minus 9.6. So because it's minus divided by minus, I can ignore the negatives. Or I can put them in if I want, you know, I could say that and that, and it'll give me the same answer. And that comes to 75.9 something. I want two significant figures, so 76. If you used a equals 5, you would get the distance to be 73. And that's okay. Okay. Question 3. Car accelerates uniformly from rest to a speed of 100 kilometers per hour in 5.8 seconds. Calculate the acceleration in meters per second squared. Give your answers to two significant figures. Right, the first thing we have to do here is convert that kilometers per hour into meters per second. So this one, bit of a pain, 100 kilometers per hour, well there's 1,000 meters in a kilometer, so that's 100,000 meters per hour. But then you're not going to get as many meters travelled in a second, because 1 hour is 3,600 seconds. I want to know how many meters in 1 second. So I have to divide by 3,600, which becomes 27.8 meters per second. So I've multiplied by 1,000 to turn the kilometers into meters, and then because it's per hour and I want per second, I've had to divide by 60 times 60, which is 3,600, to get the meters per second. And there's a mark for doing that. Right, we've got u, v, t, we want a. So a equals v minus u divided by t. Put in the numbers. V was 27.8, u was 0, t was 5.8, and that comes out to 4.789. I want two significant figures. That's 4.8 meters per second squared. Part B. I can now add that up to my data here. Calculate the distance travelled by the car while accelerating. Give your answer to two significant figures. This time we want S. So I need to use v squared minus u squared equals 2as. Substitute in my data. 27.8 squared minus u was 0, 2 times 4.8 times s. Work out what I can. 27.8 squared take away 0 squared is 772.84. 2 times 4.8 is 9.6. Then to find s, I've got to divide 0.84 divided by 9.6, which is 80.50 something. If I round that to two significant figures, it's 81. Alright, well done if you got all those. Right, here's the challenge questions. These don't use any different equations. There's just the wording is a bit different, or you might have a little bit more to do. Or there might be some hidden information. And question 4 is a good example of a question with some hidden information. Okay, a cricketer throws a ball vertically upwards so the ball leaves his hand at a speed of 25 meters per second. So we've got u is 25 meters per second. The acceleration due to gravity is 9.8. Assume air resistance can be ignored. Calculate the maximum height reached. So we're calculating a distance. You know, a height is a distance. Now, it looks like we haven't got enough information to do the question, but if you think about it, if you've got a ball and you throw it up, it's going to start with some speed, but then it's going to go up and then come back down again. And at this point here, at its maximum height, the final speed is going to be 0. So actually, v equals 0. They've just got a weird way of telling us that, saying calculate the maximum height, and then we've got to understand that when the height is the maximum, the speed of the ball is temporarily 0. Now that has got another effect. If the speed is going from 25 to 0, it's not accelerating, it's decelerating. So I must put in a minus. Right, so our equation is v squared minus u squared equals 2as. So 0 minus 25 squared equals 2 times minus 9.8 times s. 0 minus 25 squared is minus 625. 2 times minus 9.8 is minus 19.6 times s. So we've got a minus on both sides, so we could just get rid of those. And we end up with 625 divided by 19.6, which is 31.88. And I'm going to write that to two significant figures, 32 meters. Right, part 2. Calculate the time taken to reach this maximum height. Well, I have enough information for that already, so calculate the time. I've got v, I've got u, and I've got a. So I'm going to use the equation a equals v minus u over t. So the acceleration was minus 9.8. Oops, wrong colour pen. Never mind. Equals v was 0, u was 25, divided by t. So minus 9.8 equals minus 25 over t. If I rearrange that, I can drop the minuses. 9.8 times t is 25. T must be 25 divided by 9.8, which is 2.55 something. So I'm going to round that to 2.6 seconds. Question 5, the super challenge one. The only thing that makes this one difficult is that you have to treat the motion as being 2 stages. So part A is fairly straightforward. Part B, you have to use some information from part A to give you the answer. And part C is fairly straightforward, it's just tedious, it's long because you've got to use the same equation twice. You'll see what I mean when we get there. Right, the thrust SSC car raised the world land speed record in 1997. The mass of the car was 1 times 10 to the 4 kilograms. So let's put that there. A 12-second run by the car may be considered in 2 stages of constant acceleration. Stage 1 was from 0 to 4 seconds and stage 2 was from 4 to 12 seconds. So we're not using a time of 12 seconds, we're using a 4 seconds and an 8 seconds. Okay, in stage 1 the car accelerates from rest to 44 meters per second in 4 seconds. Calculate the acceleration produced and the force required to accelerate the car. So we've got to do 2 things in one question, which makes this more challenging. So let's take them one at a time. Acceleration. Let's see, what have we got? We've got v, we've got u, we've got t. So we use a equals v minus u divided by t. We substitute in what we know. 44 minus 0 divided by 4. So the acceleration was 11 meters per second squared. Next thing we had to calculate was the force. Well, now we know the acceleration and we've got the mass, so we can use force equals mass times acceleration. Put in the data we know. Don't know force. Mass was 1.0 times 10 to the 4 kilograms, multiplied by the acceleration was 11. So 1 times 11 is 11, that's 11 times 10 to the 4, so 1.1 times 10 to the 5 newtons. If you've not done your answer in standard form, that's okay, because the question doesn't say standard form or not. Right, part B. In stage 2, the car continued to accelerate. So stage 1 has happened and we're now on to stage 2. But at the end of stage 1, the speed was 44 meters per second. So the end of stage 1 is the beginning of stage 2. So the initial speed is 44 meters per second. Then it tells us it reached 280 meters per second. and that took 8 seconds. Calculate the acceleration. So again, we're using a equals v minus u over t. So the thing that makes this question difficult is recognizing that you've got to use that 44 meters per second again. So a equals 280 minus 44 divided by 8, which is 29.5 meters per second squared. If you'd rounded it up to 30, that's fine. Right. Part C. Calculate the distance travelled from rest to reach a speed of 280 meters per second. Now we cannot say u equals 0 and v is 280 because the acceleration changed part way through. The acceleration changed from 11 up to 29.5. So we can't just say, oh well, let's use the first u and the last v. You've got to take it a step at a time. So stage 1, let's look at our data. We had u equals 0, v equals 44, a was 11, and s, I don't know. And then stage 2, we had u equals 44, v equals 280, t equals 8, oh yeah, over here, t equals 4, u, v, t, what else do we know? Oh yes, a is 29.5, u, v, t, a, s equals that. Alright, so we've got data here, we might not need all of it. So we're going to use v squared minus u squared equals 2as. So actually we don't need the time. There are other suvat equations which if you do A level you will learn, but you don't have to do them for GCSE. You just have to do a equals v minus u over t and v squared minus u squared equals 2as for GCSE. Right, let's take these one at a time, substitute in what we know. 44 squared minus 0 squared equals 2 times 11 times s. 44 squared take away 0 squared is 1936, and that equals 22 times s. So if I do 1936 divided by 22, I get 88 meters, and that's for stage 1. I'm now doing exactly the same calculation with different numbers for stage 2. 280 squared minus 44 squared equals 2 times 29.5 times s. 280 squared take away 44 squared is 76,464. Whenever you get a number like that, please double check it on your calculator. 2 times 29.5 is 59 times s. So s must be 76,464 divided by 59 is 1,296 meters, and that's for stage 2. So the total is stage 1 plus stage 2, 1,384 meters.